Hey YouTube, Kilroy back in the shop, working on the Lipton rod bender. Kicked it off there with a little shaper action. We're working on the block that goes right here, right? So obviously already made some progress and we're going to go over it. I've said many times, the cheapest way to remove scale from hot rolled is with a shaper, because one piece of high-speed steel, like this piece of 1/2 by 8 by 1 that I've got a different cutting edge ground on each end, will obviously last well beyond my lifetime. I'll be giving this to somebody when I'm no longer able to work in the shop. So, but you touch it up on the grinder and chew the scale off all day long. The next shot you're getting ready to see is throwing on the shear tool, and we're going to put a finish on it. The tool I use for taking the scale off, the first one I used there, leaves kind of a ridged finish. I mean, you're not going to get a real good finish cutting through the scale. Just make sure that you get down below it and that you're cutting fresh material when you do it. You don't want to be in that scale layer, right? Make sure you get down below it. And anyway, so let's go on to the cut with the shear tool as we put a nice finish on here. All right, so you can see how that shear tool works. It's got a radius on the bottom. It's 45 degrees to the direction of travel. Shears off a nice chip. Later on in the video, we're going to try using that shear tool more aggressively. I've always wondered, you know, why can't I take a deeper cut? And I can, and we're going to do it. But what we're going to try next is, I got kind of experimental and wanted to kind of experiment with a grind to see if I could use more of my shaper's feed. It's a GE shaper, and minimum feed is 10 thousandths per stroke. It goes all the way up to like 120, I think. Anyway, so I wanted to be able to chew off that scale. I wanted to be able to get up into maybe, say, 40, 50, 60, 70, 80,000 feed per stroke. As you know, when you're just chewing the scale off and you're not really terribly concerned about finish, but I don't want to leave it looking like a phonograph record either. So I did this first grind with a little bit of side rake, relatively light back rake, both, and then rake down both sides. Ultimately, what I'd like to come up with is, I'd like to come up with a tool that I could feed both directions. So I could feed across, lower my tool, feed back, lower my tool, feed back, so that I'm not always moving the workpiece back and feeding back over. So a tool that would work in a bi-directional manner. So this is kind of my first pass at that. So let's check that out. All right, when you saw me kick off there, I think I was running 60 thou per stroke. Worked okay, but it was obvious to me that I had too much radius on the bottom. So this next, I took it over to the grinder, and again, I'm not really trying to get the finish on this tool perfect and get everything perfect. I'm just playing around with grinds to see what works. And so I went over and ground most of the radius off the bottom, and now we're going to try another cut here. All right, so you saw the first tool. It was really tearing real bad. Wasn't so much cutting the material as it was rubbing the material. So I removed a lot of that radius, made sure I got the tool vertically, made sure the leading edge was cutting the material, and much better, much better. So it's still not a finished tool, but it'll get you, it'll remove that junk and get you a good surface that you can move on to without any trouble. So then what we did, we took, now that the block is in woodworking terminology S4S, right? And it's time to cut this relief here. This is 1.26 deep long relief and almost ½ inch, 0.462. And the way we're going to do this is we're going to take one cut at 380. Then I had to go back and calculate the depth of this radius. This is the 1.5 inch radius that rolls against this pin, against the pivot. And I calculated the depth of that radius, and then went and had to adjust this cut back to compensate for this depth. So we make 2 passes. We're using a 1.5 inch rougher, 6 flute rougher, and we're going to make this cut in 1 pass. You'll notice while the cut's going on, there's a couple of sparks the cutter throws. It's because the bottom of this cutter is fairly, I mean, it's time to get touched up, or it's seen a lot of action. The bottom edge, right? That's always where your cutters wear the most. And it's got a nice radius on it. So I think it's got like about a 1/16 radius on it. So anyway, that's what that spark is from. Is by no means a difficult cut for the machine. So anyway, let's get over and watch these 2 cuts. So we'll have 1 cut across, then we'll have another cut to get to that full length 4/62, and then we're going to plunge cut in to get the 1.5 inch radius that rides along that pivot. So let's go over to the Kearney Trekker and check that out.
Okay, so
this is where we stand right here. I do have to point out that in between this video and the last, I did weld the pivot boss on. And it was my first time TIG welding an actual project, and it probably wasn't the easiest thing to begin my TIG welding time with, but I did it. So I'm going to show you some pictures that I have, a little kind of like a small slideshow of what of this process. I did not take any arc shots or any video. 2 reasons. 1, I'm not equipped to take arc shots. 2, there is only one thing you should learn from me when it comes to TIG welding. And that one thing is, if I can do it, you can do it. That's it. I am not even moderately accomplished at TIG welding, a flat beginner, and I don't want to be spreading any bad habits. But so check out these pics right now. So there you go. It's on here. Everything spins. I'm a little concerned about welding this piece on here and having it pull this ring out around. So I'm a little concerned about that. So I think what I'm going to do is I'm going to weld this on here first and then drill the holes in here after the fact to make sure that in case I do something stupid and bodge up the welding, that those holes are indeed vertical as compared to the plane here of this ring. If something was to warp or tilt or cock in some way that is not quite kosher, if I pre-drill these holes, who knows. I am going to drill the hole in the back here for the handle. So what I've decided to do for the handle is drill and tap a hole for a 5/8 bolt, and then use that stub, or is it a 3/4? Use that bolt stub as a way to put a handle, a pipe handle or something like that on. And then the idea being that if you bang something up, dent something, whatever, you can replace it. So anyway, we're going to do that next. We're going to drill and tap here for the handle. Let's get over to the mill and hit it.